Hello from Hamburg, Germany. Welcome to QCon Plus and this session where I'm going to tell you how I built a search for my weblog. And now, why is this interesting? And I think it's interesting because this costs me for 10K requests 4 cents. And really, I don't even have that many requests. So essentially, it costs me nothing. And this is possible because I chose a serverless implementation approach for this. So this is running on AWS Lambda using their serverless technology. And actually, you can take a look at it right now. So you can go to my weblog at morling.dev, and there you have the search control in the upper right-hand side. And if you put some search text in there, it will search my website. And really, this talk is about how is this implemented using serverless technology. And there should be 3 key takeaways in this talk for you. So first of all, I am going to discuss why I think serverless is a good solution for this particular problem. Secondly, I'm going to talk about how you can implement serverless applications using Quarkus, which is a development stack for building cloud-native applications. And lastly, I'm going to touch on a practical matter, and this is cost control. So how can we prevent what's called a denial of wallet attack? And also, I hope I can debunk some common misconceptions and myths in the course of this talk. So a while ago, I did this little tweet storm, which I called Mythbusters Serverless Edition. And I was trying to address a few common misconceptions I hear again and again. Things like you couldn't use Java for implementing serverless just because of the longer time it might take to start up. Or things like there's automatically always something like a vendor login if you go serverless. And I hope I can convince you that those things actually are not true and how they are not true. Actually. A few words about myself. I work as a software engineer at Red Hat, where I am focusing on the Debezium project. And Debezium is a tool, an open source platform for change data capture. If you're curious what this is and what you can do with it, I would very much recommend you check out my talk I did at QCon San Francisco last year, which you can watch on InfoQ.com. I'm involved with a few other projects, such as Quarkus, and this is actually the technical foundation of the search feature, which I'm going to talk about here. Now, to bring everybody on the same page, let's just briefly discuss a serverless definition. So what is this actually again? And you can read it yourself. This is the definition by the Cloud Native Computing Foundation, CNCF. I really like this one. And essentially, they say it's a computing model which describes how you build and run applications without having to think about provisioning servers or managing servers yourself. So somebody else, in my case, this would be AWS, is taking care of this. And also, there's this notion that this is executed, scaled, and build on demand. So this means if there's no workload, no requests are coming in, everything is scaled to 0 and you don't have to pay anything for this at all. But then if there's a spike in load, tons of requests are coming in at the same time, it will automatically scale out, it will be able to serve this load, and all this happens automatically for you without you having to think about how this actually works too much. Now, why did I think this is a good use case for my weblog? And really, I should mention, this is a static site which runs on GitHub pages. So it's just a set of static HTML files. And this means those kinds of dynamic functionalities like a search, you can't really do this there. You need to have something more dynamic. And now I didn't feel like using an external service like, let's say, the custom Google search, because I wanted to have control over how this is branded, how results are shown, and so on. So I wanted to do it myself. But at the same time, I didn't feel like using a traditional application server stack and things like that, because it would mean I need to install an operating system, something like an app server. I need to keep this up to date, install all the patches, security fixes, and so on. I just felt I didn't want to have to do this. I felt I would like to have some sort of hands-off experience. So really, going serverless for me means there's a smaller attack surface. I just need to focus on my actual implementation of my app, and this is the code I'm dealing with, and this is which I need to keep up to date. But then all the environment, all the server infrastructure, somebody else is taking care of that. So it's more secure for me. Then there's this matter of a lower cost factor. So really, as I mentioned, I just have a very low volume of load. This means, in serverless, I will get away with just a few cents or maybe not nothing at all to pay. So that's really cool. But then don't be fooled. It doesn't mean that serverless always would be a cheaper solution. If you have like a high constant base level of load, you might be better off looking into alternative approaches. But really, for this particular use case, serverless is very cost attractive. And finally, to be frank, it was for me a learning experience. So I really wanted to learn how I can implement something running on Lambda, using things like Quarkus. How could I actually go about this and solve this particular problem I had for my website? Now, let's take a look into how this actually looks like. So this is like the overview, and this is, as I mentioned, the static pages. They are served from GitHub pages. So I'm using Hugo, which is a static site generator. This produces HTML, which then is served via GitHub pages. And now, if a search request comes in, so if you go to this little text control, you put some query there, this actually will invoke the API gateway, which runs on AWS. So this is done via some sort of AJAX request, you could say. It goes to the API gateway, which then routes the request back to the actual serverless implementation, which is running on AWS Lambda. And in terms of implementation, this is using Apache Lucene as the search query or as the search engine implementation. This is using Quarkus as the development stack. And finally, it's also all runs with GraalVM native binaries. So this means there's no JVM involved. It runs as native code. And this is because it gets very fast to start up that way, much faster than I could do it on the JVM. And in terms of a serverless cold start user experience, this is exactly what I'm after. Now, the question, of course, is how do I actually index my data and my blog posts? And luckily, Hugo provides me some help there. It can generate a JSON file which contains essentially just the text of my blog post. And you can see it here on the right-hand side. So this is a nicely processable data structure with all the contents, the tags, publication date, all those kinds of attributes. And now this is the basis for my search service. And now I do one trick, actually. I index everything at build time. So if I do a change to my weblog, like a new post, I also need to update this search service. But really, this makes it, again, a bit more secure for me. So my actual application at runtime, it's immutable. It is just read-only. This means there's no way you could write to it, which is just more secure. And also for my use case, I don't update this content too often. This is just fine then if I actually do it also to rebuild this application and that way benefit from an immutable application image. In terms of the search engine itself, this is using Apache Lucene, as I mentioned. And really, this is, I would say, the go-to standard search engine, search library in Java. So that's what you're looking at. It's driving things like Elasticsearch or also Solr, but you also can use it as a library, which is what I'm doing here. And it has all the things like word stemming, so you can look for words in different word forms, plural, singular, different verb forms, and so on. There's result highlighting, so you can see this on the website. The results are nicely highlighted, so you actually see some sort of context with your query match and things like that. And also there's other advanced search features like fuzzy search or proximity search. And also really, this is why I didn't feel like implementing this using JavaScript on the client side, because such a mature library such as Lucene provides all this for me ready to use. Now let's spend some time and think about how we actually can implement such a search or such a serverless application using the Quarkus stack. And there's different ways, and I will explain you just briefly how you could do this, and then also why or when you would choose which one of those three approaches. So the first one would be you just could use the Lambda request handler interface, which you already might know if you have been working with Lambda on Java before. So you can just use the Lambda SDK, implement this, and then Quarkus makes this for you usable on the JVM, but also in a native binary via GraalVM. So that would be the first option. The second option would be what's called Funky, and this is actually very interesting. It's a dedicated function as a service framework, which is part of the Quarkus umbrella. And really the idea there is to provide you with a very easy to use programming experience, which then targets different function as a service environments. So you could use this with AWS Lambda, but you also could use it with Google Cloud Functions, Azure Functions, and things like that. And the idea there is you just define a single method here, which takes the parameters of the function as a method parameter, the input, and then it just returns something. So it's a plain Java method, and Funky takes care of mapping this to Lambda and all those kinds of execution environments. So that's Funky. And the last option you have for implementing a serverless application with Quarkus would be just to use your traditional web stack. So you can use things like Vertex, maybe just even Serverless or REST Easy, JAX-RS, things like that. And actually, that's what I went for here. And there, if you ever have done some REST development using Quark or using Java, this will look very familiar for you or to use. So here I'm using JAX-RS. I use all those annotations like add add get, add producers, and so on. And really, this is my classic way how I would implement this. And then Quarkus actually takes care of mapping the Lambda invocation to the right in the right way, so this web endpoint for me gets invoked. Now, when would I use which one of those three approaches? And I would say I would go for the request handler approach. Really, either if I had existing code, maybe I already have an existing application and now I would like to move this over to Quarkus and maybe a native binary, then I would use this. Or if I really were in the need to use specific APIs from the Lambda environment, then I would use this. Otherwise, I would not really go for that, because it really means I am now limited. I'm locked into this environment, and moving somewhere else would be rather tricky. I would use Funky if I would get away with it. So it really is a very basic function-based approach. This means it just maps simple get and post requests for me. I couldn't, for instance, do something like an HTTP delete. But really, if this is enough for me, then I would go for this. And to be honest, back when I built this, Funky was just not as far as it is by now. Maybe I would have gone for it. But actually, well, back then, I went for the web stack because this gives me the full flexibility. So maybe I use things like HTTP headers, cache control, all those attributes, content negotiation. Well, I can do this using a web stack like JOX-RS, and this is why I went for that. I felt I just would like to have this flexibility, but also this makes it very, very portable. So actually what I can do now is Quarkus builds a Lambda function.zip file for me, which gets deployed to the Lambda environment. But really, I can just easily build this for other environments just by matter of configuration. So let's say I would like to run this on Kubernetes or Knative, which is the container-based serverless approach. Well, I just can use this because I already have a portable web application. And now what I did in my example, or in my project release, I put this dependency, the Quarkus Amazon Lambda HTTP dependency, I put this into a separate Maven profile. And now either I enable this profile and then I build my project, my search for being executed via AWS Lambda, or I don't build it with this profile, I just disable that profile. Well, then I just build a regular jar, an executable jar. I can very easily put this into a container image using tools like Jib, maybe, and then I could put it to Kubernetes, Knative, and all those services which would interact with plain Linux container images. So I have no login at all. I'm just very, very portable here. Now let's talk about cold starts, because really this is the biggest concern around serverless. This means if a request comes in, it could be this application has been scaled to 0 before. In my case, this would be very likely because, as I mentioned, I don't have a high load. So this means, in all likelihood, if you go there, it won't be running, and it must be starting up very quickly so that the user doesn't have to wait there for a long time. And now Quarkus helps a lot with the startup times, because what it does is it has this notion of a compile time boot. So it does many, many things which your traditional stack would do at application startup time, like scanning the class path for dependencies or entities, things like that. Quarkus does all those things already at build time, and then essentially bytecode gets recorded which describes this information, and it gets baked into the application. So this makes it faster to start up on the JVM. But really, if you want to go to the next level and have like a startup in terms of milliseconds, then you would look at native binaries via GraalVM, and Quarkus makes this very easy for you to do this. And then you're looking at startup times in the range of milliseconds. So let's say on my local laptop, this search would give me a time to first response, so the time between startup and first result, of below 50 milliseconds. So that's definitely very, very acceptable. In the Lambda environment, it depends a bit on how much resources you have assigned. You would look maybe at 200 or 300 milliseconds, but still it's acceptable, and it gives you like an instantaneous feel, so that the user doesn't have to feel and they need to wait for the cold start there. Now, there's a challenge with native binaries and GraalVM, and this is you cannot just use all the tools and tricks you did in your Java application in a native binary. There are things like reflection, method handles, calling code of the Java via the Java native interface. You cannot really do this just as easily because, well, GraalVM does lots of optimizations, and it does things like dead code elimination. So it analyzes your application, and then if you don't use a specific method or constructor, well, this would not be part of the native binary, and then it couldn't be used. So that's why reflection just cannot be used out of the box. Instead, you need to announce, you need to configure which are the types you are going to reflect on. So this is why if you take such a library as, say, Scene, you just cannot take it and it would run out of the box in a native binary. In all likelihood, you need to do some preparatory steps for that. And now Quarkus comes with a set of extensions there. So the idea is for a very large range of property dependencies, Quarkus enables their usage in GraalVM native binaries. So things like Kafka clients, Hibernate, Vertex, Camel, MicroProfile, all those things, Prometheus, and so on. There are Quarkus extensions for that. And then this means you just add the right extension to your project, and then all this configuration will be made for you, and you can use this in a native binary. Now, in my case, for Apache Lucene, there was no Quarkus extension for this yet. So this meant I was a bit on my own, but really it's not too hard. Essentially, it's a bit of a matter of trial and error. You give it a try, you see how far you go in the native binary, and then you can react to that. So just to give you one example, in Lucene there is what's called the attribute factory, which is a factory which instantiates those attribute classes, which are essentially like metadata attributes of an index. And now this attribute factory, it uses reflection to instantiate those types. And now what I actually did is, it doesn't use reflection, it uses this method handle. Actually, in this case, it cannot be used. There's different ways how method handles can be used, and this particular one is not yet supported by GraalVM native binaries. So what did I do? I created what's called a substitution. So GraalVM and the native binary creation allows you to substitute specific classes. So in that case, I just provided my own version of that attribute factory where I just use plain method calls to instantiate those attribute types. And now this class is used instead of the original one, and this problem is solved for me. And then I have this extension. This still is quite specific to my use case, but ideally I would make this a bit more generic, and then others who also would like to use Lucene would be able to use this as part of the Quarkus extension ecosystem. But there's more we can do. So we can go to a native binary and optimize the cold start times, but also we can improve the situation further just by observing how this actually is going to be used. And in this case, I figured, okay, if a user is putting their mouse pointer into this text input field, in all likelihood, just shortly thereafter, they are going to execute a search. And this is what I'm leveraging. So if you look closely here at the network tool in my browser, what I actually do is as soon as you put the cursor to this text input, it already will send a request to the backend. And this will actually take care of starting up the environment if it wasn't started before. So now this means if like a second later or 2 seconds later, you actually submit your query, you will already hit an started up environment, and you don't even perceive the cold startup delay at all. So this is one way how we can further improve this. So now, lastly, I would like to talk about this matter of cost control. So the problem there is, this is a private project for me. It's a side effort. I don't have an operations team which would be running and monitoring this for me 24/7, which means I really want to be sure there isn't such a thing like a denial of wallet attack. So this means somebody just comes to the search, invokes it again and again and again, and as it is serverless, which means I pay per use, potentially I would be in for a bad surprise, and I would have to pay for many, many requests, which I don't really want, of course. Now the question is, how can I avoid this? And there's a few measures you can do to make this really safe. And the first thing to do is put an API usage plan in place. So you can see it here a bit on the screenshot. You can do things like saying I would like to just have 50K requests per month, and if it goes beyond that, no more requests are accepted, and that way no more requests will be built. But there's a problem with that, and this is what's called the coarse pre-flight request. So if you have such a sort of an Ajax-based integration into a website as I have it, this means the browser will send this pre-flight request, and there you cannot have any custom headers. And this means I cannot pass the API key, which in turn means I cannot use this API usage plan. So those coarse pre-flight requests, they still are kind of unlimited. I cannot really limit them. And this is why I put in place what I would call a budget circuit breaker. So I found a very nice blog post about it. Essentially, the idea there is to just have another Lambda, and this one essentially reacts to a budget alert. So I have a budget alert set up, which triggers if I reach a specific amount of spending on AWS. And if this alert triggers, then this Lambda gets invoked. And what it does is it spins down the rate limit and the burst limit of the API. So this means 0 requests per second are allowed once this actually has kicked in, which means I wouldn't be charged for any more requests coming in. Now, there's just one more problem with that, and this all is asynchronous. So this could mean it could take a few hours even until this circuit breaker really kicks in. And still during the time, somebody could still be invoking those cause pre-flight requests lots of times. And that's why I put throttling in place. So just to rate limit the number of requests. So in my case, this is a private page. You know, I don't need more than maybe 100 or maybe just 50 concurrent requests. So this would be plenty. So I can just further limit down the speed of how quickly this would pile up. But really, to be ultimately safe, in the end, I put all of this behind Cloudflare service workers, and there they have a very good free tier essentially, which allows me to handle all the coarse requests over there. And then if it goes beyond their free limit, it will just be cut off. And in my case, I'm just fine with that. This is not business critical for me, so I'm just fine to shut it down after I think 100K requests per day, and then it would cost me nothing at all. And that way, I'm really safe, and if I sit on a plane or I'm on holidays, I would not be at risk that this gets out of control. To wrap it up, I definitely sense there was quite a steep learning curve with Lambda. So there's things like IAMD, identity and access management. I found this is a really tricky beast. It's hard to understand what is the minimum set of permissions you need. It takes you quite some time to figure this out. Then there's also other subtle things like actually there's a correlation between how much RAM you have assigned and then how much CPU cycles you would get. So essentially, or actually, I would get away with 128 megabytes of RAM for my search there, but really I have assigned 512 because that way I get more CPU shares and just the end-to-end latency is a bit lower. Requests are served quicker. So that's another thing interesting to keep in mind. So more RAM does not necessarily means it's better, might not be worth it. But then really with all the learning, I found Quarkus helps me a lot. So as we have seen, it avoids this login. So I'm not bound to the Lambda specific interface. I can implement my serverless feature in different ways, just using a regular web stack such as StruxRS. But then there's other things that, for instance, creates templates for SAM. So that's the serverless application model, which is another tool from the Lambda ecosystem, which makes it quite easy for me to deploy such a serverless application. And now my Quarkus application, I can generate this actually. I can go to code.quarkus.io and I just add right dependencies to this, like or the Lambda dependency, and then this will generate a scaffolding for a new project for me. And this already contains templates for the SAM tool for me. So I'm just like 2 commands away from deploying this to Lambda and have it running. And finally, really for me, the most important takeaway, because as I mentioned, it is a personal side project, you definitely should think about how you prevent those denial of wallet attacks. If you come back to those myths and misconceptions, I hope I could convince you that you definitely can use Java via GraalVM native binaries. Cold starts are not a problem, really. And also, it doesn't mean a login. So as you have seen, there's a very good portability story here. You just could move this functionality to other clouds or just even to Kubernetes or Knative, and you wouldn't have any sort of login at all. And I would say those myths, I would hope I could help and bust them a little bit. Finally, a few resources. So really, this post is essentially, this talk essentially is a condensed version of a blog post, which, surprise, you can find on my blog. So there you can read up in all detail about all the things which I've been talking about. Also, all this is open source, so you can just take this and put it to your own blog, to your own site if you want to. Feel free to do it. It's Apache licensed. Then if you would like to know more about Quarkus, which is driving all this, go to quarkus.io. And lastly, I have this blog post I found by this engineer Harish, which was very helpful for me to implement this budget circuit breaker. So definitely check this out too. And with that, I'm done. I look very much forward to discussing with you in the chat and answering all your questions, hopefully. For now, thank you for listening.